Are we live? Okay, yes we are. Right, so I'm actually a bit early today. The past few days I've been streaming at around 4:30, but today I'm starting at 1:30. I'm trying to fix my schedule. I'm trying to sleep early and wake up early. It's in the work, right? Okay, leaving that aside, today besides Leetcode, yesterday I actually found out something. I mean, since I suck so much at development, that is something I've been very clear about since the very start. Yesterday, I just found out that Leetcode also has a JavaScript section. I didn't know that. There's a 30 days JavaScript mastery like that on Leetcode. So I think, first of all, I've seen people ask JavaScript in a lot of interviews. On top of that, I'm not that good with how things work in JavaScript. So I thought it would be two birds, one stone. I learn JavaScript, and this will not only make me better in JavaScript, but also like help me in development, right? So first, of course, I think I'll do one or two DSA questions. After that, I I intend to probably start those lead code JavaScript question, but I think I'll have to read a bit about JavaScript first. Right. Enough yapping. Let's get started. Not, hmm. Okay. Yesterday, what what was I doing? Okay, yeah. Yep. I was doing this question yesterday and I made it incredibly complicated, where in fact it was simply we have to find the smallest subarray with the GCD as 1. That is the question, right? I made it incredibly complicated, right? Even though this thing that I wrote, this is completely okay, right? We return -1 if the GCD of entire array is not equal to 1. I could have realized that this exactly is what the question is asking, like find the subarray whose GCD is 1, but I don't know, bro. I tried doing BFS and whatnot. Look at this. That's not how we're going to do it. We just want to find the smallest subarray with GCD equal to 1. Hmm. Okay. Yep. Makes sense. Hmm. Minimum number of operations. Find the smallest subarray with GCD equals to 1. And after you get that, what you need to return is the rest of the elements plus that length of the subarray -1, right? Exactly, right? Here, the smallest subarray with GCD equal to 1 is. No, wait. How is output 4? I had an example with myself. Hmm. Okay. So we had this example. 6 and 9 have a GCD of 3. 10, 6, and 9 have a GCD of 1. Exactly. This has a GCD of 1. But what would be the answer in this case? The answer would be we, right. The answer would be we write the GCD of 6 and 9 as 3 over 6, then 10 and 3 GCD as 1. Right. Now, since we have 1, using this we can make 2 and 10 as 1. Uh, 2 as 1. Right. Hmm. And we can write 1 and 3 as 1. Bro, what? 1 and 3 as 1. And 1 and 9 as 1. 1, 2, 3, 4, 5. What? What would be the answer for this case? 2, 10, 6, 9, 2, 10, 6, 9. So for case 3, yeah, it's 5. That's the point. Which question am I doing? Yesterday's POTD, bro. I I was solving it on live stream yesterday, but I had to go somewhere, so I'm doing it again. Okay, so the answer is 5 because this is the smallest subarray, and to make things 1 here, to make things 1 here, we'll have to go 10, 6, 6, 9. Why is the answer 5 here? Ten, 6, and 9 gives a GCD of 1, right? 10, 6, and 9 gives a GCD of 1. Now to make 3 elements as 1. What? What if we wrote another 6? In this case, it's 7. It's 7 because if we had another 6 here, the smallest subarray to return a GCD as 1 would be this. Now, it would take 10, 6, and 9 to convert every element as 1. We took how many? Here we're taking 6 attempts, right? Yeah, here we're taking 6 attempts. Here we're taking 1 attempt. Now for 10, 6, and 9, here we're taking 5 attempts. 3 plus 2, 4 plus 2. Okay, so it's just length plus 2. Not exactly. If we had a 6 and 7, if we add a 6 and 7, we can write 6 as 1, right? We get 1, 7, and then we write 1 and 7, and then we can write 7 as 1. So in 3 attempts, here it's 3. What am I doing wrong? Wait, I need to clear a few things out. For 2, 10, 9, right? 2, 2, 10, 6, 2, 10, 6, 6, 9, 2, 10, 9. 2, 10, 6, 9. Okay, let's see. For 2, 10, 9, we're getting the output as 3, right? Because 10 and 9, 1, 10 becomes 1, and then, okay. The output is 2. Wait. No, yeah, the expected is 3, right? Why am see, bro? For 10 and 9, it takes it 2 steps. For 10, 6, and 9, 10, 6, and 9, it takes it. Okay, it takes it 4 steps. For 10, 2, 10, 6, 6, 9. For 2, 10, 6, 6, 9. 9. It takes 6 attempts. 2, 3. No, not 2. 2 is not involved here. We're only talking about this. We're only talking about this. It takes 6 attempts to convert 4 elements into 1. What am I doing wrong, bro? That's the point. 6, 6, 9. So for 10, 6, 6, 9, we're getting 9 attempts. That means 1, 2, 3, 4, 5. So for 1, 2, 3, 4, we're getting 8 attempts. What am I being confused at now? Hmm. So for 10, 9, it takes 2 attempts. For 10, 6, 9, it takes 4. Okay. 4 elements, it taking 6. 4 elements, it's taking 6. Right. For 5 elements, it's taking 8. Okay, so it's just... Oh, come on, bro. I get it now. Okay, smallest subarray with GCD C, and then we return... and we return len minus 1 star 2 plus remaining elements. Okay, now we just need to find the int GCD finder. Okay, yeah, GCD finder is going to take in your vector. Let's run the very brute force method over every subarray. We start from the smallest. We start from the smallest. Yep. See, that's the point, right? Bro, which year? You can't go to college? See, I'm in my 4th year, so we don't really have to go to college. Early stream today, exactly. Yes, I woke up early today, and I think I'll get done with Leetcode in the morning. Probably then focus on the development in the evening. What's up, bro, Kirtan, bro? Okay, so... You know what? Int... Bro, I can't type. I less than your error.size I plus plus for int j equals to 0, j less than, not 0, I plus 1, not I, j less than error.size j plus plus. But this will not help us find the smallest subarray, bro. Why am I making it complicated again? Do we need a GCD finder? I don't think so. Rev GCD equals to error I prev GCD prev GCD equals to GCD between prev GCD and ARR J. Okay, if prev GCD equal to 1 equal to 1, then we can say smallest smallest len equals to smallest length equals to uh, minimum between smallest length comma j minus I plus 1. This is going to tell us the smallest length, right? Let's test out. See out smallest length. This is going to tell us the smallest length of a sub array with GCD as 1, right? Okay, what am I doing? From where did you learn DSA? Nothing particularly, like a lot of different sources. Nothing particularly, like Striver, Lovebubber, Neatcode. Okay, yeah, 3 4. The STD out here is 3 4. Here, yeah, it's what? Okay, it's returning -1 because of here. Here it's 2. Here it's 3. Here is 4. Okay, we've solved it. We've solved it now. If now what we need to return is int n equals to arr dot size. What we want to return is return smallest length -1 2 star. Okay, plus the remaining elements. Plus the remaining elements. Now how do we get to know smallest length? N minus smallest length, right? This is what the answer is, right? Yep. Okay, so this is it. Submit it. Okay, bro. Yes, sir. For 1 the output is 1. Why is okay? So we need non-zero elements. Yeah, we need to calculate the non-zero elements. Okay. This is adding all the rest of the elements, but we need non-zero elements. How do we handle this case? So this is the number of steps to make that subarray as 1, and this is the number of steps to make the rest of the elements as what we can do is we can count 1 int 1 count int 1 count equals to 0, le equals to 1. We can do a 1 count. 1 count equals to le equals to 1. So 1 count plus plus, right? Or else 1 count plus 1. Okay. Okay. Now in the end we just minus 1 count minus 1, because in this case this would be -1. This case should work now. Bro, can you do Code Forces contest and Code Chef? It's easy in placement. I mean, easy in placement, what do you mean by that? Okay, we got a wrong answer everywhere. Ellie. Oh, okay. Okay. Hmm. No. Just a minute, bro. Int to minus equals to if one count is more than one. So we can say 2 minus equals to one count minus one, or else it's zero. Hmm. 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 For preparing for placements. Code forces. I am thinking to I'm thinking to start giving contests on code forces, but I think it's too tough for me. Do you give contests on code forces, Anish, bro? Okay, it works. It has a 54% acceptance rate. Medium well. Okay. Hmm. How does it have 54% acceptance rate? Have you crack any company? I do have an offer as of yet. I mean, I'm yet to receive my offer letter. I fail every math questions. Does anybody know how to solve this in big O of one time? No, you can't. Bro, what is this solution? Who's this guy? Alkut 20. That is crazy. Let's check it. C++ enjoyer. Okay, he hasn't solved anything. Right, so this question is done. Yes, bro, I do contest code forces and code chef. So how tough are they from Leetcode? How tough are they from Leetcode? You are think like a good problem solver. Thank you. I appreciate that. You're given a binary string. You can perform following operation on the string any number of times. Choose any index from the string where I plus 1 is less than such that si equal to 1 and okay. We need to choose 1 0. Move the character si to the right until it reaches the end of the string or another one. For example, we we bring this, we choose this resulting string 1 2 3 4 5 6 1 2 3 4 5. What the hell happened here? Move the character si to the right until it reaches the end of the string of another I. For example, si, if we choose I equal to 1, we chose this where si equal to 1 and I plus 1 equal to 0, right? The resulting and then we move the character si to the right until it reaches the end of the another string. Okay, so we just move this to this point. Okay. Return the maximum number of operations that you can perform. To perform the maximum number of operations, we'll try to bring everything to the maximum right. We can't move this. This is one operation, it goes here. This is two operation, it goes here. Three operation. So isn't this just wait? Okay, I get the logic. What we want to do is we want to count how many ones are there. No, 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 no. No, it's not that simple. What's the length? 10 raised to 5. First two problems are easy, but then hard questions, they are challenging. Tough but enjoy. Okay, so you've started enjoying code forces. Nice, bro. I might give someday. Probably. I might. I'm thinking of like I have a plan that I at least reach a rating of probably 1700 and then try on code forces. Hmm. Hmm. Okay. I do have some logic for this in mind. For this question, right? For this question, all the ones that are there from the right end are completely useless. Okay, are completely useless. So we might as well just ignore this. Might as well just ignore this. Bro, what the heck? Right. This is of no use. Now this is our string left. We want to move everyone to the right, maximum right, to the right, in the maximum possible steps. Hmm. In the maximum possible steps. If we wanted to, we could bring it here, then bring it here, and then bring this here. But that's not maximum possible steps, right? We first bring this here. Hmm. Okay, I think we first bring this here. We first bring this here. And now when these three are together, we just bring this here, and this guy here. Right, that's why there are four steps. Okay. How many problems have you solved till now? About 100 on code forces, and on Leetcode I have solved around 317. 317 on Leetcode, 100 on code forces. Hmm. You know what? In here, first of all, Leetcode has given us trash examples. Let me write a few examples of my own. Let's say we have 1 0 1 1 0 1 0 1 1 0 1. Okay, this looks like a complex enough example. First of all, again, all the ones that are already, no, bro, all the ones that are already on the extreme right, we don't care about them. Now, to maximize the steps to bring all the ones on the right, we'll first start from the leftmost, bring it towards here. So it becomes, so ignore this, and it becomes triple one, right? So we have one step. Now we move this here, this here, this here. Okay, so we get plus 3. After plus 3, it becomes this. Okay, then we have a 4 length. We move it one step. Then we get a plus 4, right? Then we get a plus 4. So it becomes this, and this is erased. Now we have 1, 2, 3, 4, 5, 6, and we want to move it 2 steps. That is plus 6 plus 6 plus 12. So what's the answer for this number? Let's see. Mine 9 is coming as 12 plus 7 plus 8, 20. If the answer is 20, then my logic is correct. Let's check out. Bro, what? You can't copy this. Bro, do you have GitHub account? Like how many projects you made? I do have a GitHub account, but see, I'm very bad at development. The expected is 14. What? How is the expected 14? The expected is 14 because wait. Yeah, I think I'm on the right track. I just miscalculated it. We have 1 0 1 1 0 1 0 1 1 0 0 1. Okay, so this number is of no use. Delete this. Coming to the other numbers. We move this to the right. So what do I do, bro? We move this to the right. So this becomes 1. This becomes 1. Okay, and so we get a 1. Now to move these 3 elements to this place. 4, 5, 6. Yeah, I have the correct logic. I have the correct logic. And I think I can solve it in big O of 1. Big O of 1. Yeah. I'm also bad at development. Exactly, bro. That's why today, as I told you, like you guys could read in the title that I'll be doing JS questions on Leetcode. My daily routine doing POTD Leetcode, then in code forces, at least 2 questions. Damn, how many questions have you done on code forces, Anish? I mean, if you can share your profile. Hmm. Okay, I have the logic in place. I have the logic in place. Okay. So we have a int gap equals to 0, int one length equals to int one length equals to 0, int answer equals to 0, or int for car C of S. We have very simple if we see a 1. No, what are you doing? If C equals to 1, if we see a 1, we increase one length. I need to open the gate, just a minute. Okay, so we see As soon as we, why am I getting confused when I have the entire logic in place? What we do is, I'm stuck on the coding part. At this point, we know that our zero length would end because the next element is 1. So we'll find all the 1 length that's before it, and we want to move that 1 length to this place. Okay, we want to move that 1 length to this place. Okay, makes sense. And I equal to 0, I less than n, I plus plus car c equals to si, 9. If c equals to 1, there's a case, and if c equals to 0, that's the case. Okay, now the point is, if c equals to 1, then of course our 1 length plus plus. Okay, 1 length increases. Yeah, that's it. We don't have much to think about c. And if c equal to 0, our gap increases, and if it is the last gap, check if it is the last gap. How do we check that? If I is not equal to n, and I is not equal to I plus 1 is not equal to n, and s of I plus 1 equal to 1, then that means it's the last gap, and we need to move answer plus equals to 1 length star gap. Okay, and then your gap becomes 0. Yep, and in the end you just return answer. I think I have one mistake here. Let me just see as of yet. We're getting 20. Okay, so our logic is wrong. Oh, I should not multiply it with gap. Okay, I don't even need gap. Answer plus equals to 1 length. It's working. Okay, I'm pretty sure this is correct. Bro, the output is 2. Oh, we'll also need to add at the end, right? If s n minus 1 equal to 0, then what we do is use this test case, then see if this is working or not. Yup, it is. There's no way this is still wrong. Cool. Wasn't really that tough, to be honest. Yeah, it has a 60% acceptance rate. How many solve this question? Observe the pattern on pen and paper. This question was very easy for being the third one. This was a third question in a contest. That's crazy. Why don't I get questions like these in a contest? Okay, do we start JavaScript now? I feel like we should. Let's start JavaScript right now. Implementation for binary search trees. Library for binary search trees. Let's look at this library. .h. What is a .h file? That's crazy. Okay, let's focus on JavaScript. See, this is what I was talking about. Designed for JavaScript beginners, master basic JavaScript skills, support high quality editorials, learn JS basics with 30 questions. We can do this. Okay, we can do this. Write a function, create hello world. It should return a new function that always returns hello world. Okay, a function returns a new function that always returns hello world. Constant f equals to create hello world, and then he's calling. So it's going to console.log hello world. Is that what it is asking for? That always returns. Oh, okay, we want to return not. See, you guys could already see how bad I am. Is this how we're gonna do it? Return function. Bro, I think I'll read a JavaScript tutorial before doing this, or else I'll just embarrass myself. What even are the test cases here? Start. Can function be stored in variables? Let's read the tutorial for this. I hope it's free. Yes, it is. You know what? I'll move myself out of the way. If you're new to JavaScript, it is recommended you to follow along with the code example. You can do this by pasting the code in Leetcode Playground. An awesome thing about JavaScript is a browser has a built-in execution environment. You can read. There are two main ways to define a function. That's crazy. Two main ways to declare a function. One of which is to use the function keyword, right? We can either define this Leetcode Playground. Let's just open that, right? Where's the playground? Has anybody ever here ever used Leetcode playground? Where's the playground, bro? Where is it? Interview learn. Wait, what are these? I've never seen these. These must be paid, right? No, they are free. Bro, I never explored Leetcode beyond the DSA problems. New playground. Console application. What is this? Not C++. We want a JavaScript. Okay. JavaScript, there are two main ways. One is to function keyword, function name, parameter, constant, sum. Okay. F is the name, A and B are the arguments. You can write any logic in the body and finally return a result. You're allowed to return nothing and it will implicitly return in undefined. Anonymous function. You can optionally exclude the name of the function after the function keyword. Oh, so this is an anonymous function where f equals to function is going to take a and b, constant sum equals to a plus b, return sum. How do we call this now? Okay, so it's console.log f with 4 and 9. 13. If I write things outside this function main, will they work? Oh, they will? What even is the use of this then? Okay, so that's just for fun, I guess. You can create a function and immediately execute it in JavaScript. See, JavaScript has so many things, bro. You can optionally exclude the name of the function after the function keyword. I did that. Okay, what am I doing? So this is an option. We can also have a function f1 is going to take a comma b, constant sum equals to a plus b, return sum. That is another f1. They're still going to run, right? And if we do console.log sum and we return nothing, so now it's going to first 13 and undefined. Yep. Encapsulate a variable within a new scope. For example, another developer sum can't be used anywhere outside the function body. Who the hell would write something like this? Uh, Variable x equals to what? That's what they've written, right? Oh yeah, they've written that variable x, it has a function and the variables that goes into that function p comma q. That function takes a comma b, and then it's going to return a plus b. Console, not p, let's have 10 comma 20 console dot log x. How do you write code like this? It gives you the opportunity to encapsulate a variable within a new scope. For example, another developer can immediately see that sum can't be used anywhere outside the function body. Okay, so this cannot be used anywhere. Function within function. Bro, this editorial is so goddamn useful. Okay. Hmm. Currently, which year you are studying? I'm in my fourth year. When a function is created, it has access to a reference to all variables declared around it, known as lexical environment. The combination of the function and its environment is called a closure. This is a powerful and often used feature of the language. Lexical environment and closure. It has access to a reference to all the variables declared around it, also known as passes the first passes the first parameter a, and the inner function has access to it. This way, creator array serves as a factory of new functions, with each return function having different behavior. Create adder would give 3. What is b here? What is b? What is b here, bro? You gotta understand what is b here. Oh, b is something. Okay. B is something that we use when we see. That's the point. Okay. Location and code. Not where it's code. Outer. You can access A because of lexical scope. Inner. Closure is what happens when a function remembers the variables from its lexical scope even after the outer function has finished returning. Mm-hmm. Mm-hmm. So, a closure is what happens when a function remembers the variables from its lexical scope even after the outer function has finished running. In your example, when creator adder finish, its variable a equal to 3 would normally disappear, but the inner function still has access to a because of a closure. Confusion, closure, bro, closure. Adarsh, hello, bro. What's up? How are you doing? Inner is inside outer, right? So inner can see messages because of its lexical scope, where it's written. Inner can see message. Output hello. Returning the inner function. Now let's return the inner function instead of calling it. Okay. Hmm. Constant greet equal to outer. Outer returns another function which is inner. Greet. It's not going to. Oh, it's it run and we store it in greet. Now when we call greet, what happens? Hello. Wait, outer has already finished running. Normally the variable message should be gone, but inner still remembers it. Okay, so this is what a closure is. A function that remembers the variables from the place where it was created, even after that place has finished running. So when outer finishes, its variable normally disappears because inner was created inside out. I get it. I get it. I get it. Arrow syntax. Yeah, this is the thing I hate the most about JavaScript. Constant function equals to parameters arrow this omit omit return. You can omit the return. This can result in very short code. What is hoisting? Function return function hoisting where a function can some that's useless. Closure still makes sense. Arrow syntax, yep. Omit return, we can omit return. There are three major differences between arrow syntax and function syntax. More minimalistic syntax, you're only allowed to use a function after it was declared. Can't be bound to this super. To access all the past arguments as an array. This isn't necessary for this, but it will be. You can basic syntax. Oh, all the past arguments as an array. Hmm, makes sense. Makes sense. It may not be immediately obvious why you would use this syntax because you can always just pass an array and get the same result. The primary use case is for creating a generic factory function that accepts any function as input and return a new version of that function. Which, by the way, a function that accepts a function and or returns a function is called. Oh, well, the primary use case is creating a generic factory function that accepts. Yeah, this is what we use in catch async function, right? Where was catch async function used? To catch errors in asynchronous function. Catch async. Bro, I can't. By the way, a function that accept any function as input and return a new version of the function with some specific modification. For example, this is taking an input function and it's going to return a function with all the arguments being spread out. Rest arguments. Input function and asks. Hmm. See, JavaScript is so damn stupid. Yeah, that's what JavaScript is just misery exactly. Like, who the hell in their right mind would create a language like this? Return an arrow function, return arguments. Like, what? Why do humans love to complicate things? Of course, bro. This is nonsense. Like, who the hell is going to write a stupid ass code like this just to return hello world? Stupid ass thing. Your English is awesome. That's crazy, bro. I think I'll end the stream here. JavaScript is frying my brain at this point. Yeah. Hmm. I'll. What is it? It is Thursday. Okay, so we have a contest on Sunday. So it's still far. But yeah, I guess I'll end the stream here. We'll. Yeah, but this editorial for JavaScript was really useful. I'll continue doing this, but from tomorrow. Okay, so that is it for today. Thank you. Bye bye.